Welcome to my presentation. I will be describing and discussing lead chemistry, including examples and uses of organolead compounds and reactions. Some general just lead chemistry, simple stuff. Lead is the largest crystallogen. This means that the bonds are weaker than the bonds formed by other elements in the group. The weak bonds that lead forms mean that its organolead compounds form much weaker bonds, unlike other metals in this group like tin. R6Pb2 is one of the only organolead compounds where there's actually two lead compounds bonded together. It's obviously because the PB bonds are very easily broken. So chain and ring compounds that are just made of lead that have lots of PB bonds are just unknown. Um, and so most organolead organometals that have lead in the general structure of like R2PB, something similar than that. You know, they can be a bit different, but generally it's something around that. One of the most important things about lead is the inert pair effect. The inert pair effect, sort of simply put, means that the two of uh, the two outermost electrons in the s orbital are in a stable position. The E cell potentials for lead Pb2 plus and Pb4 plus show this effect. So if you see the Pb2 plus has a very low E cell and Pb4 plus has a very high E cell, that's because this is very stable due to the inert pair effect. This is not. Obviously, it's a high E cell, and if you have like a very high E cell, your delta G will be negative because of this equation, delta G equals NFE. And obviously, when you have a negative delta G, the reaction will be spontaneous. So this wants to go down to more stable Pb2 plus. This doesn't want to go down to a just Pb with no charge, again because of the inert pair effect. Again, that's just what I've said. Yeah, the reaction there. So some general synthesis of organolead compounds. The most common way to synthesize organolead compounds of the formula R4Pb is to react lead chlorides and organomagnesium or organolithium in ether. You start off with your metal, so magnesium or lithium, bonded to 4 ligands. With the lead chloride, 2 molecules lead chloride, producing your R4Pb. But that's sort of the general reaction scheme of it. There's 3 steps in that kind of reaction. First one being reacting the 2R-MgX, X being just any sort of halogen with the lead chloride, producing R2Pb. These R2Pb molecules and join together to produce R6Pb2. But this is not that stable, so some heat, it will go to R4Pb, getting a product there. One of the most important types of research being done on organolead compounds is the perovskite solar cells. And these sort of have a general formula of ABX, where A is CH3 NH3 plus, and B is obviously the lead, and then X is like CLI or Br. These have become a very popular type of solar cells, in research because of their very high absorption ability. Just a simple example of that would be CH3, NH3, PbI3. It's synthesized by spin coating lead nitrate as a lead source onto titanium oxide and then sequentially dipping it into methylammonium iodide solution. So there's been some recent advances in organolead perovskite solar cells. The first sort of long-term organolead perovskite solar cells had an efficiency of 9.7%. In the space of a year after that, the efficiencies they could get were as high as 16 or so. As these types of solar cells are new, other advancements are expected to be made. There's a typo there, but organolead halide perovskite solar cells are one of the most promising and cutting-edge type of solar cells, like I've said. Sort of some general other information that I thought was interesting but didn't really fit in, but yeah, I thought I'd mention it. There's been no real conclusive evidence of sort of radicals, the R3 pH radicals, but it is believed that they might be possible at low temperatures and as intermediates in organolead reactions. Organolead compounds can also be used as a common additive to gasoline, and actually this type of additive produces a sort of lower concentration of nanoparticles from the exhaust, which is good. So that's sort of a quick summary of things we talked about. Sort of the general lead chemistry and the inert pair effect, and the reactions to synthesize organolead compounds. Some common uses for organolead compounds. The most sort of significant in research, like new research, being these perovskite solar cells. So that's it. Thank you for watching.